All right, so I know we briefly talked about segment and angle addition postulate already, but I want to take today and tomorrow to kind of go back over those and actually apply them and practice some proofs with them. All right, so remember the segment addition postulate says if 3 points are on the same line segment, so that is collinear. Oh, that's a highlighter. And B is between A and C, then from A to B plus from B to C equals the length of the whole thing, so AC. Okay, so remembering that, let's look at some examples. So, example 1. If DF equals 10, right, so our entire segment is 10, and from D to E is 7, what is this portion from E to F? So you will take the whole thing, which is DF, or 10, and subtract DE, which is 7, to find that that length is 3. Okay, number 2. If M to O is 32, so from here to here, if that whole length is 32, find the value of x. So we know that from M to N is 2x, and we know that from N to O is 3x plus 7. So if we add those two things together, we know that that entire length has to be 32. So now we have an equation that we can solve. So we'll add our 2x and 3x together because they're on the same side, right? So move the 7 over. So 32 minus 7 is 25. I'm just copying this over here so I have more room. Divided by 5. So x is 5. So again, to set up that equation, I just added the two pieces together and set it equal to what we know the whole thing is. So 2x plus 3x plus 7 set equal to 32 because that's the length of our entire segment. And then used algebra to solve our equation. Okay. Number 3. So if R to U is 59, so the length of our entire segment is 59, find TR. So we're looking for this chunk here. So we have to figure out we need to figure out what x is first, right? Because we have to add 7 and 3x minus 4 together to find R to T. But we can't do that since we don't know what x is. So just like in our last problem, we're going to add everything together. So 7 plus 3x minus 4 plus 4x. And set that equal to 59. Then we're going to find x. So I'm going to combine my like terms of 7 and negative 4, which is 3, and 3x plus 4x is a 7x. Equals 59. Add 3. Oh, sorry, I messed up. You're subtracting 3. I was going to say that doesn't work right, but now it will. So those 3's cancel. 59 minus 3 gives you 56. So 7x equals 56. Divide by 7. And x equals 8. So now that we know x equals 8, we can plug that in for this x right here. Okay, so 3 times 8 minus 4. 3 times 8 is 24 minus 4. So 20. So from S to T is 20, and we know R to S is 7. So to find R to T, we're going to do 7 plus 20 and get an answer of 27. All right, so let's look at example 4. We are solving for x, and then we have to find the length of each segment. All right, so again, we are going to take our three pieces, x plus 15, and 3x. And then we'll set them equal to the whole thing, which is 10x plus 5. So, a bit longer of an equation, but that's okay. Nothing we can't handle. So, x plus 15 for the middle piece, plus 3x for the end piece, equals the total of 10x plus 5. So, on the left side, we're going to add x plus 3x. So, 1x plus another 1x is 2x, plus 3x is a 5x. Bring down that 15, equals 10x plus 5. So I'm going to move my 10x over here. So 5 minus 10 is negative 5x. Bring down my 15, my equals, those canceled, and a 5. Subtract my 15 over. So negative 5x equals, so my 15's cancel. 5 minus 15 is negative 10. Divide by 5, negative 5, sorry. So x equals a positive 2. So if x is 2, then this piece is 2. The middle piece, we're going to do 2 plus 15 to get 17. And our end piece, we'll do 3 times 2 to get 6. Okay, so now that we've gone through those, let's, why is that happening? Hold on. There we go. All right, so let's look at this proof. So we are given that JK is equal to MN. So this piece is congruent to this piece, right? So our first reason is given. Okay, so then the next part, we wrote the statement that JK, there we go, JK plus KL equals JL, right? So how do we know that? What postulate tells us that? Hint, it's the one we are taking notes on, right? It's the segment addition postulate. So sometimes we can use postulates. Oh my goodness. I'm not worried about that. It's just not going to be in place anymore. Okay, so sometimes we can use postulates to write the next part of our proofs, right? So that is the segment addition postulate. Yes, I'm abbreviating, okay? So that's how we got that piece of information. Okay, so then now, how did we get from 2 to 3? So looks like the JL's the same, the KL's the same, JK changed to MN. And we know that those two things are equal, so we are just substituting those, right? So that would be substitution. All right, and you just did technically your first geometry proof now. Okay, so for most of these on the next page, which is practice for you guys, I think next 2 pages. Okay, so these first 8 are just like the algebra one, just like the first examples we did. These 2 pages today. So 1 through 8 here, and then these last ones are just like the proofs that we did. So your reasons for these are just going to be either given, segment addition. You can have some transitive subtraction, but for the most part, you're using segment addition and substitution. Okay, so try and figure out how they got those. Do your best, help each other out. If you have questions about specific ones, please email me, and I will be happy to answer your questions. All right, so I want you guys to work on, it's really practice problems, and then the proofs 1 through 4 on the next page. Email me, let me know how far you get, or just Coach Booth, if you don't care to let me know how far they get. Let me know if you need more time tomorrow, and we'll go from there.